So you just finished building an awesome 4x4x4 RGB LED cube or a 10x5 LED matrix, and you want to control each LED individually. The matrix contains of 50 LEDs and the cube of 3x64 LEDs, so 192 LEDs. And that's the moment you realize that you are screwed, because none of your microcontrollers have this many I/O pins. Not even the Arduino Mega with its whopping 54 I/Os is enough. So I'm going to show you how to control many LEDs with only a few I/Os. And I will only use an Arduino Nano, one TLC 5940 LED driver, 5 P-channel MOSFETs, the F9540N, one 2K resistor and 5 1K resistor. I think the principle is easier to explain with an LED matrix, so let's build one. I just solder my LEDs to a PCB like normal, but now happens the magic. I connect all cathodes or negative pins of all LEDs in one column and repeat this process for all columns. Now I connect the anodes or positive pins of all LEDs in one row, and I made sure that the anodes and cathodes touch nowhere. And it's done. Now I have my 5 anode rows right and 10 cathode columns down. I also soldered some female headers to those to make connecting easier. And just for better view and programming for later, I labeled the columns from A to J and the rows from A to E. This maps my LEDs clearly like it's shown in this schematic. Now we connect positive voltage to A and ground to A, and LED AA lights up. That could save us a lot of I/O pins of the Arduino. As long as we only light up one LED, everything works fine. But when we want to light up AA and GA, we also light up JA and AE, so this does not work. That is when we use multiplexing. We light up each row individually and one after the other, but we go through the rows so fast that our eyes don't notice and just see a static complete picture. But one row can draw up to 200 milliamps with 10 LEDs, so we cannot connect those to one I/O. We have to use a P-channel MOSFET as a switch. I'm using the F9540N and connect gate to my I/O, source to 5 volts and drain to the anode rows. And I use 10 outputs of my TLC 5940 for the 10 cathode columns. You can take a look at my schematic to get all the connections right. Gate of MOSFET row A to nano pin 8, MOSFET row 2 to pin 7, row 3 to pin 6, row 4 to pin 5, row 5 to pin 4. This is also written in my Arduino code, which you can download. TLC pin 28 to column 1, TLC pin 1 to column 2, TLC pin 2 to column 3, and so on until TLC pin 9 to column 10. The rest wiring of the TLC is well described in the schematic. We also need 5 1K resistor as pull-up resistors between the gate of each MOSFET and 5 volts, and one 2K resistor to set the constant current of the TLC to 20 milliamps per LED. Okay, let's get to the code. Working with the TLC can be really difficult if you write the code from scratch, but that is not what we want. We're gonna use a GreatScott library from the Arduino playground. Just place the library in your libraries folder and you can include it in your sketch. The code is much easier than it looks like, and I wrote it by myself, so there's tons of things to optimize and criticize. If you just upload the code like this, you should see a moving sine wave. I also made the static word how and the moving letter E. Nothing spectacular. And here we see what happens when I increase the on time of a row. We can clearly see that it's not one complete picture, but single rows which light up one after the other. If you wish to understand the code a little better and use it, then go ahead and download it. I comment every line and hopefully make it easy to understand. As you can see, it works quite well with the sine wave, and I will use this concept in my upcoming video of the RGB LED cube. I hope you learned something today. If so, don't forget to like, share, subscribe, and I will see you next time.